Okay, so you're all on air now. All right, so we're going to move on to probabilities using counting methods. Sometimes in some questions we'll use what we did before in terms of chapter 4 and using the different methods that we use to figure out a lot of things at one time. Or other times it's easier just to use fractions. So depending on the question, we will look at different strategies. So it says recall the probability. That probably should say recall that probability is defined as the number of favorable outcomes divided by the total number of outcomes. Remember that basically means what you want divided by what you could get. Okay, so that's basically what you're doing there. Sometimes we will have to determine the number of outcomes using combinatorics, and that's basically what we were using last chapter about counting methods. And we used lots of different strategies on how we can find out the total of something. So example number 1, we have Jamal, Ethan, and Alberto. They are Alberta, as Malcolm requested. They are competing with 7 other boys to be on their school's cross-country team. All the boys have an equal chance of winning the trial race. Determine the probability that Jamal, Ethan, and Alberto will place first, second, and third in any order. So think back to last chapter. How would we have come up with the number of combinations of placement? How would we have calculated that?
7 choose 3.
Not 7. You got the choose 3, right? Okay, yeah. So there's 10. There's Jamal, Ethan, Alberto, and the 7 other boys that are competing. So in order to figure out how many different ways that they could place, we have 10 choose 3, which is a number. And so therefore, the probability one of those combinations will happen in 10C3. So calculate 10C3, if you remember how to do it. Which is 120. That's right. So you can leave it as 1 over 120. You could calculate to a decimal, which would be less than 0.01 because it's more than 1 out of 100. So I don't know if it's worth to calculate to a decimal. Plus remember, every time you're converting to a decimal, you're losing value because you're going to round off. So 1 out of 120 is a pretty reasonable answer. And in fact, it's the most accurate answer you can give because you're not converting to decimal and rounding off. Okay, so that's one example of using what we've done in the past chapter to calculate an answer. Now, I wouldn't use that method in example number 2, which says determine the probability of out of 5 children, all of them are boys. So this one is different. This one I would look at the probability of each child being a boy, because when we're looking at 5 different things happening, because they are different, each is a different item, we're just multiplying the probability of each, okay? So what is the probability that any child will be male? What is it? Yeah, 1 out of?
What if you're a twin?
2. What if?
Well, still the same. No.
So, determine the probability of out of 5 children, all of them are boys. So, we'd be looking for probability of 5 boys. That's right. Why is it 1 out of 2? There's 2 different things it can be. What you want is a boy, 1. Out of how many things it can be? 2. So the probability of 5 boys on the first boy, the first child I should say, what's the probability that it could be a boy? What about the second child? Third child? 4th? You're on a roll, Carter. 5th child?
1 and 2.
Nice. Therefore, the probability that of 5 children, all will be boys
32.
1 out of 32, which does convert to a decimal, but we have to round it off. So why not leave it as 1 out of 32?
You don't have to round it off, do you?
Yes.
You can round it off.
All right, example number 3. A morning radio show is holding a contest at a local mall. The host spells out Vancouver with letter tiles. He then turns all the tiles face down and mixes them up. If that contestant arranges the tiles in a row and turns them face up and spells Vancouver, they win. Oh, that would be sort of difficult, but what's the probability that that person will win?
2 to 1. Oh, I'm 2. Okay.
So, what are the number of arrangements? What are all the different ways that that contestant could turn up the tiles?
Well, I mean, is there any doubles?
Good question.
Thanks.
9 factorial.
9 factorial because
there's 2 V's.
Can't use in the same letter.
9 factorial because there's 9 tiles divided by
2.
2 factorial, which is the same as 2. Why?
Because it's 2 V's.
Yes, because we have repeats. So it doesn't matter which V it would be. So 9 factorial over 2 factorial is 181,440.
I'm so easy.
So, so the probability will be 1 in 181,440. Boys, shh. You can play this for your mom now, Carter. It will be evidence of how many times I have to ask you to be quiet.
You talk your quote at a time.
She can hear you right now.
Pretend you.
Moving on, example number 4 is the big one. And our last example with 3 parts. All right, we have 4 boys and 7 girls that have signed up for a trip, but only 4 students will be selected. So determine the probability that, first of all, only girls will be on the trip. So in order to determine the probability, we're going to be figuring out the probability that a girl will be chosen out of the total amount chosen. So how many different combinations can girls be chosen? Because we're wondering if only girls will be. Let's do the total. What's the total combinations of students being chosen? How many students are there?
11.
11. Choose 4. Well done. Because we're choosing 4 students. Okay, that's the total different combinations. Now what about the girl combinations?
7.
7. Girls, choose 4. Yeah.
Neat.
So you can calculate each separately and divide them. You could fire that into your calculator and divide them. 7 choose 4. 35. 11 choose 4. 330. Yeah, that was lame. Good. So we're at 0.106, which converts to roughly 11%. 10.6%, approximately 11. Okay, try B on your own.
Couldn't you just reduce the fraction?
You could divide by 5, so 7. If you wanted to leave it in fraction form, yes. Try B by yourself. There will be equal number of boys and girls. There, I did half of it for you.
number. Okay, got it. But there's 11 people. 11 people, that can't be even number. It can't be equal.
They're choosing 4.
You said it's an equal number of boys and girls.
That would be
There's
2
11.
each. Yes. Out of the 11, they're choosing 4, remember?
Oh, to go on the trip.
Yes.
Okay, I didn't read the second part.
How would I represent equal boys and girls? What would the girls be? 7 choose 2. The boys would be? 4 choose 2. Yes. You might have said it, I just couldn't hear you. All right, so out of 330, 7 choose 2 multiplied 4 choose 2. What is it?
126.
Thank you. You could reduce to get 63 out of 165, which actually continues to reduce because 165 is divisible by 3. I think so. There we go. Decimal is? Yeah, so we have approximately 38%. Okay, finish up. More girls than boys. Calculate it to a percent. So if there's more girls than boys, how many girls?
3.
And 1 boy. So we're going to have 7 choose 3, multiplied by 4 choose 1. The top works out to 140. Okay. Which reduces to 14 out of 33. That one was easy. So 0.424, which is approximately 42%. Okay. So we've used a lot of different methods to calculate. Use the one that makes sense to you. Okay, lots of different ways. Once you've kind of gone over the different kinds of questions, hopefully you have enough strategies to answer.
For C, does it mean that there has to be a boy on the trip? On the trip? Yeah, because yeah.
You're right. No. You could have 4, so you'd have to do and. Okay, so let's finish it up. You're right. There will be more girls. That could mean there's 4 girls, right? And no boys? Did we already do 4 girls?
Yeah, I really did those.
But it says it includes boys in the question. So.
There will be more girls than boys.
Yeah, it can only be that.
No, I think you could interpret it either way.
Wait, what? What did he do? Or,
Wait, what?
what was the other one? He did 4
What if there are
girls.
only girls on the trip?
So you could go 3 girls.
But there's no boys.
What do you think?
I don't know. I'm not. It says more
4.
than
4 girls is more than 0 boys. Like, it does meet the criteria.
A specifies only girls, so why would C wouldn't specify that? So it would specify one.
You guys are tens. Oh, it says.
All right, so let's put a star. If you also considered 4 girls in this scenario, it's a really good question, you guys. Then you would have 0.424 plus what? 0.106. Or roughly a 53% chance. I think you could convince me either way as long as you told me your reasoning. If you said something like this, I'd agree with you. If you didn't, I'd agree with you. It's a good question. Alrighty, let's practice. So on page 321, try 1 to 4, 7, 11, and 15. I did that on purpose. I didn't do it on purpose. All right. We should watch it for fun now.
Should we watch?
Oh, that's